Let's solve this implicit differentiation problem step by step. We'll find the derivative dy slash dx of the equation x cubed, y plus x, y cubed equals 2. First, let's understand what we need to do. We'll differentiate both sides of the equation with respect to x using the product rule, since we have products of x and y terms. Remember, when differentiating with respect to x, we need to use the chain rule for terms containing y, since y is a function of x. Let's start with the left side. 4x cubed y. Using the product rule, we get 3x squared y plus x cubed dy slash dx. 4xy cubed, we get y cubed plus 3x y squared dy slash dx. Combining these terms and setting them equal to 0, since the derivative of 2 is 0, we get 3x squared y plus x cubed dy slash dx plus y cubed plus 3x y squared dy slash dx equals 0. Now let's group the terms with dy slash dx together. This gives us x cubed plus 3x y squared times dy slash dx equals negative 3x squared y minus y cubed. To solve for dy slash dx, we divide both sides by x cubed plus 3xy squared. This gives us dy slash dx equals negative 3x squared y plus y cubed over x cubed plus 3xy squared. Finally, we can factor out y from the numerator and x from the denominator to get our final answer. dy slash dx equals negative y times 3x squared plus y squared over x times x squared plus 3y squared. And there we have it. We've found the derivative dy slash dx through implicit differentiation. This gives us the rate of change of y with respect to x at any point on the curve x cubed, y plus x, y cubed equals 2.